Then we will study the concept of pulse-wise 4 times. The 4 concepts: amplitude, rest time. Come in.
这个不行是吧？
这里部分它是可以不太常见。
它下回来吗？
目不是。哦，很正常。哦，
这个3主题不许没用，是小问题。
好的，谢谢。
我是这样的。
谢谢。OK。The third term, pulse-wise, 4 times. The 4 terms is very important. It's very important. So we must understand what the meaning of amplitude. Amplitude
The
from
difference of baseline and
the mean value of this high value. The mean value of this.
we did it calculus to find the meaning there. Calculus.
Yes. And the most fluctuating wave is called overshoot.
What is amplitude?
Amplitude.
Yeah.
Yes, it is the difference value from the
Mean value and baseline.
the lowest value to the high value.
What's the value?
The high value. And the high value is the mean value of this value. Of this value. If we use a simple definition, we just call the amplitude is the value difference between the lowest value to the highest value. Understand? Okay. And the second is rest time. Rest time is from the point which represents the 10% of the amplitude to the second point which value is 90% of the amplitude. Yes, so it is called rest time, and the symbol is TR. Time. Right. So we use TR to represent rest time. And the third term, pulse-wise. Pulse-wise is represent the time difference between the one point which is located in the reading time line, which value is represent 50% of the amplitude to the second point, which value is also 50% of the amplitude. But this point is located on the 4 time. So the time difference between these 2 points is called pulse-wise. This is a pulse, and the time difference between these 2 points is called pulse-wise. And the symbol is TPW. TPW. P pulse W Y EPW. And the four terms, four times. It is defined time difference between the pointer whose value is 50% of the amplitude to the pointer which value is 10% of the amplitude on the 4H. So it is named 4 times, and the symbol is TF. F represents 4. So the 4 terms is very important. And the other terms you only use to understanding the meaning. This is called ranging. And the most fluctuated wave is called amplitude. The most fluctuated. This is the pulse definitions. Periodic and non-periodic pulse waveforms. Periodic and non-periodic pulse waveforms. This is periodic pulse waveform, because it repeats. Okay, one again. You know. Please see this figure. The times T1 and T2 and T3 are all the same. That is to say, T1 equals T2 equals T3, and so on, and equals Tn. So the period of this periodic pulse waveform is T1. And the frequency of this waveform is 1 over T. Frequency. These two concepts are also very important. Frequency.
T equal 1 by F and S equal 1 by T. What is frequency equal? Frequency equal 1 by time, fixed period. I mean, T equal 1 by F.
Yes.
1 by T.
Yes. Frequency. The symbol of frequency is usually F. F is 1 by period T. 1 by period. This waveform is periodic. Square wave. Because of the time of high level is equals the time of low level. So we call this wave square wave. the time, the high level is equal the low time, the time of low level. If we use T1, T2,
T1 equals T2.
then T1 equals T2. Then we call this waveform periodic. The second figure is non-periodic because we cannot find the period. We cannot find the period.
This T1 is not equal to T2.
Yes. Yes.
And this is also not a square wave. This is not a square wave.
Periodic pulse waveforms are composed of pulses that repeats in a fixed interval. The fixed interval is called the period. The frequency is the rate it repeats and is measured in hertz. So, frequency is equals 1 by period. Period is equals 1 by frequency. But the unit is t. The unit of t is seconds, and the unit of frequency is hertz. Understand?
Yes. And also the hertz and circle per second. These two units, hertz and circle per second.
Yes. Second. The clock is a base timing signal. That is an example of a periodic wave. Clock just like this waveform. Clock wave. This is a clock wave. Clock wave. What is the period of a refractive wave? If f equals 3.2 gigahertz, you can use
3.2.
you can do some calculation.
Yes, sir. This one.
What is the unit?
This is in second. 3.125 into 10 inverse 10 seconds. This one, sir.
Very good.
Second.
We know the period is equals 1 by f, and f equals 3.2 gigahertz. Gigahertz.
10 to the power 9.
Yeah.
Giga.
1 gigahertz
10 power 9.
equals 10 hertz. So we must use this equation, and the result is 313 PS. PS, what is it? PS.
This is the picosecond. Pico.
1 PS equals
10 inverse 10.
10
Inverse 10 power minus 10. Minus 10
minus 10.
seconds.
Oh, Very good. Very good.
That's good, sir.
Right?
10, sir. 10.
10.
Yes, sir. 6 or 7.
No.
Right.
You can see. This is 300.
Oh, 300. But my result is at 3 point.
Not
1, 2,
not 3.0 seconds.
So I
Yeah.
get this one.
Yes.
So if I do 3, 1, 3,
Yes.
so 6 or 7.
Yes. This is minus 12.
Yes, sir. Sorry.
1 PS equals 10 minus 12
Second.
and second. We can do some 1 and S
10 inverse 9 seconds.
9. Yes. And 1
Mu.
mu.
10 inverse 6.
Yeah, 10 by 9 6. And
Milli.
me.
10 inverse 3.
Yeah.
1 iota, sir.
Okay. Okay. 1
Tera.
and
10 to the power 6. 6.
10 6.
Mega. Kilo. 1 kilo.
Yes, 1 kilo of
Yes.
this. Then
3. 3, sir. And this one, sir. 1 tera 10 to the power 12.
Yeah.
Terabyte. And 1 iota equal 80.
yes.
And common is
Very good, very
50.
good. Okay, you should know this equation.
This is the problem.
Timing diagram is another term. A timing diagram is used to show the relationships between two or more digital waveforms. The first signal is clock signal. It is period signal. It is a period waveform. The first clock, the first period, the second period, the three period, and the eighth period. In the first period, the value of A is high level, and the value of B is low level. The value of C is low level. A, B, C are three different digital signals. You know?
Yes,
A is a signal waveform. B is a signal waveform. C is another signal waveform. In the first period, A is high, B is low, C is low. And in the second period, A is low level, B is high level, C is low level. And in the three period, A is high level, B is high level, and C is low level. In the fourth period, A low, B low, C high. In the fifth period, A high, B low, C high. Below C high. In the sixth period, A low, B high, C high. In the seventh period, 1 1 1. In the eighth
High. 0, 0, 0.
0, 0, 0. So this figure is called timing diagram. Timing diagram. Serials and parallel date. Serials and parallel date. Date can be transmitted by either serial transfer or parallel transfer. Serial transfer or parallel transfer. You know, this kind of transfer is serial transfer. The date from the computer can be transmitted, making use serial date transfer to modem. Each time the modem can receive one bit.
101.
Yes. 1011 0010. And the parallel date transfer. The date can be transmitted parallel. So for example, the printer. We use printer to print the papers. Say the printer can receive many bits one time. Can receive many bits one time. The 1, 2, 3, 4, 5, 6, 7, 8. The 8 bits is transmitted to the printer one time. So you should disregard serial transfer and parallel transfer. What are the difference between these?
Series and parallel.
Yes. Basic logic function. And produces a high output only if all inputs are high. Okay. If the AND has two inputs, such as
A, B.
this
A, B.
A, B, and Y.
A, B.
Y. If A equals 0, B equals 0,
Y equals 0.
Y equals which value?
0.
0. If A equals 0, B
Equal 1.
equals 1.
0.
0. If A equals 1, B equals 0, Y equals
0.
0. If A equals 1,
B equal 1 equals 1.
Y equals 1.
This is the multiplying itself.
Yes. This is the function of AND. Function of AND. Because the all inputs should high, then the output will be high. This is the function of the AND gate. And all gates producing the high input if one or more inputs are high.
This is the gate value. This is multiply.
Yes.
And OR gate. I am doing.
Or
I do.
or
Plus B. 0, 0, 0.
or
1, 1.
please see the blackboard. Please see the blackboard.
OR gate.
Yes. This is a blackboard. The symbol is another state. Another state. All gates choose you know.
Yes, sir.
And if A equals 0, B equals 0, then
0.
where equals 0. A equals 0, B equals 1,
1.
Y equals
1.
1 equals 1. A equals 1, B equals 0, Y equals 1. A equals 1, B equals 1, Y equals 1. 1.
NOR gate.
Yes. This is a function of all gates. All gates. It is called all gates. The third logic function, not changes one logic level to the other logic level.
If I give 1,
Logic level. What is logic level? Logic level, high level and low level. You know? High level and low level. Is that logic level? Not change one logic level to the other logic level. So if the input, the level of the input is high level, then the output is a low level. So if A equals 0,
Y equal 1.
then where 1. If A equals 1,
0.
then Y equals 0.
And then you then you
Yes.
0, 0, every 1, 0, 1, 1, 0, 1, 1. Then gate. And the 1, 1, 0.
We only study the three basic logic functions.
And the XOR gate.
Yes. Very good.
Very good.
The NOT operation. This is the NOT operation. Change one logic level to the other logic level. High level change to low level. Low level change to high level. And this kind of operation is performed by a circuit called inverter. You should know what is inverter. What is inverter? It in fact is a NOT gate. NOT gate. This inverter is a kind of digital circuit. It's a kind of digital circuit. It's a kind of circuit. It can perform NOT operation. The AND operation produces a high output only when all inputs are high. So all inputs are high, then the output is high. Others, they will be low. They will be low. And the AND operation is performed by a circuit called on AND gate. AND gate. And all operations produces a high output when one or more inputs are high. If one or more inputs are high, then the output is high. The output is low. And the OR operation is performed by a circuit called OR gate. So inverter, AND gate, OR gate are three different circuits. The comparison function, and OR and NOT elements can be combined to form various logic functions such as NAND. And the comparison function indicates whether a binary value is greater than, equal to, or less than another, such as A and B. A and B are two different binary numbers. The function of the comparator is if A greater than B, then the output of this is 1. If A equals to B, then this output is 1. If A less than B, then the output of this is 1. So this kind of gate comparator has 2 inputs and 3 outputs. For example, the binary code of A is 2. How to represent 2? Use binary number. If we use 4 bits, to represent 2. There are binary number. It equals 2. What is the binary number? 5. 0.
5 binary number 0010.
0010.
5.
No. 0, 1,
Oh, 5 binary.
0, 1
Oh,
equals 5.
oh.
Why? Why? Because it is binary. It is steps. Yeah. And
Logic.
it equals to 0 multiply plus 1 multiply 2 multiply 0 multiply you know, the first bit, its constant is 2
or
0
0.
to 0, and this bit is weighted by 2 1, and this bit is weighted by 2 2. This is weighted by 2 3.
Yes.
So we can calculate this 0 0 2 0 plus 2 plus 0 plus 0 equals to 2. So 2 is represented by 0 0 1 0, and 5. 5 is because it is equal to 1 multiplied to 0 plus 0 multiplied to 1 plus 1 multiplied to 2 and plus 0 multiplied to 3. This value is
Yeah, 1 and
1
1 plus
1
plus
plus
0
0
plus 4
plus 4
plus 0.
plus 0. So it is equal to 5. It is equal to 5. So the two binary codes are 2 and 5. So A is less than B, right? A is less than B because 2 is less than 5. 2 is less than 5. So A is less than B. The output of this is high, and the other two outputs are low. This is the function of comparator. The comparator function is performed by a circuit called O comparator, inverter, AND board, gate, OR gate, and comparator. The arithmetic functions include addition, subtraction, multiplication, and division. Add, addition, add, sum, multiply, and division. These four kinds of functions are called arithmetic functions. Add, subtraction, multiplication, this symbol, or and division is this symbol, or that, or this that. This kind of adder has 3 inputs. A and B are two binary numbers. A and B are two binary numbers. And C in is all carry in. Carry in. Do you know carry? Because you know if A plus B such as 26
You mean
26 plus 26 plus 37.
So we have carry number
6 plus 7
13. So we have carry number
is
1.
3.
Yeah.
Then
Carry number is 1.
this number is called carry.
Yeah.
You know, this number is called carry. So if we want to these two numbers and this number added, 2 is called A, 3 is called B, and this number is called carry. If each number has many bits, then then A represents many bits number. Many bits number. So the carrying maybe has many bits and many bits. Not only one bit, you know, not only one bit. Because if we want to A equals B equals to then 8 plus 9 is 7. 6 plus 7 plus 1 4. 14. 2 plus 3 plus 1 is 6. Then the two bits also called characters, you know, also called characters. So at this time, carry has two bits, and at this time, carry has one bit. Then, for example, if 3 A equals to 3, B equals to 9, and C in equals to 0, then the sum, this symbol represents the sum, and this symbol represents C out. It represents carry out. If we want to such as this one, input is A and B, And this is carrying, and this is the sum, and this is the carry out. You know, carry in, carry out.
Yes,
Carry in, carry out.
no.
Understand?
No.
Okay. We will explain this concept next time. Play the part below. So we have 1 over, so this is carry 1 plus 6 plus 8 is 15. So we have 1, this is going to multiply 2 plus 2 plus 1. So this carry is finished, so carry out. Yeah. Can I explain it? Yeah. After class I will explain it. YouTube. How I can think of YouTube? Tangent number 2.
Yeah.
Tangent number 5.
Yes.
Sa mi mu.
Yes.
You sa mi. Sa mi mu. And 谢哈普 you. 民生 you.